Here we have a SAT math problem. Okay, let's go to the question. In the figure above, AD equals to 4, measure of angle BAD is 45 degrees and measure of angle BCD is 30 degrees. What is the area of triangle ABC? Round your answer to the nearest 10th. Okay, here we have to get the area of this triangle ABC over here. In this triangle, the line segment BD over here represents the height of the triangle, and this side AC of the triangle represents a base. Okay, here once we get the length of this base AC and the height BD, we can use the formula base times height divided by 2 to get area of this triangle. Okay, now my aim is to get the height of BD and also the length of CD. Okay, once I get the length of this CD, I can add 4 to this CD to get the base of the triangle. Okay, now let's consider the triangle ABD over here. Actually, it is a right triangle. So because we have a straight line on the right side of this line segment BD, we have right angle. So on this side also we can consider right angle. So it is a right triangle. In this right triangle, we have right angle over here, and here we have 45 degrees. Then the measure of this angle has to be 45 degrees. So because in any triangle, the three interior angles must add up to 180 degrees. So here we have 45, here we have 90. Then I must take 45 degrees over here so that these three interior angles will add up to 180 degrees. And also it is an isosceles triangle because two interior angles are equal in measure. In an isosceles triangle, the sides which are opposite to the angles of equal measure must be equal in length. Okay, here the side BD and AD of this right triangle are opposite to the angles of equal measure. So the AD and BD must be having equal length. Already we have the length of AD, that is 4. Then the length of this BD also must be 4. So because these two sides are opposite to the angles of equal measure. Okay, here I got the height of the triangle BD. Okay, now my aim is to get the length of this line segment CD. How do you have to get the length of this line segment CD? For that, we have to consider the right triangle BCD over here. In this right triangle BCD, we have right angle over here, and here we have 30 degrees angle measure. Then what should be the measure of interior angle over here? It has to be 60 degrees, so that the three interior angles will add up to 180 degrees. And also this right triangle BCD is a special right triangle. That is 30, 60, 90 special right triangle. In 30, 60, 90 special right triangle, the side which is opposite to the smallest angle measured 30 degrees is considered to be the shortest leg. Here the side BD of this triangle is opposite to the smallest angle measured 30 degrees. Then this is the shortest leg of this right triangle. And usually in 30, 60, 90 special right triangle, we assume X as the length of the shortest leg. Now to get the length of the next longer leg, the side which is opposite to 60 degree, what we have to do is we have to multiply the length of the shortest leg by square root of 3. Then the length of this leg DC is X times square root of 3. And this is the hypotenuse because it is opposite to the right angle. Now to get the length of the hypotenuse over here, we have to multiply the length of the shortest leg X by 2, that is 2X. Okay, here we got the length of BD, that is X, but already we know the length of BD, that is 4. So the value of this X must be 4. Then here also we can replace this X by 4. Then we get 4 times square root of 3. That is the length of DC is. Okay, now let's get the length of the base of the triangle, that is AC, equals to AD positive DC. So the length of AD is 4 and the length of DC is 4 square root of 3. Okay, here I got the base of the triangle AC, that is base of the triangle ABC. Now let's get the area of triangle ABC. Let me write the stuff over here. Area of triangle ABC equals to the formula is base times height divided by 2. Okay, here the base of the triangle ABC is given by the side AC. Its length is 4 positive 4 square root of 3. Let me plug in this value for base. It is 4 positive 4 square root of 3 times the height of this triangle ABC is given by this line segment BD. Its length is 4. We can plug in 4 for height over here divided by 2. Okay, here 2 goes into 2 1 times and 2 goes into 4 2 times. Okay, here we can distribute this 2 to this 4 and 4 times square root of 3. Then I'm getting 2 times 4 is 8. And 2 times of 4 square root of 3 is 8 square root of 3. Okay, here I can use calculator to get the simplified value of this one. So, and also I have to round the answer to the nearest 10th according to the information. So when I evaluate the value of this numerical expression and round it to the nearest 10th, I am getting 21.9. Therefore, the area of triangle ABC is about 21.9 square units.